So what is the universe really made of? I mean, deep down. Is there like a fundamental source code to reality itself? Well, today we're going to explore this really wild theory, one that claims the answer has been hiding in plain sight all along. It's a theory that connects the deepest, most secret parts of pure mathematics with the actual laws of physics that run our universe.
Yeah, the physicist Eugene Wigner, he put it perfectly. For centuries, we've seen this almost magical connection, right? We come up with these abstract mathematical ideas just purely in our minds, and then somehow they turn out to be the exact language the universe speaks. I mean, think about it. From gravity to quantum mechanics, math just works. It's this unreasonably effective tool for describing reality, and nobody really knows why. But, this whole thing raises a much deeper question. Is math just a tool we're using to describe the universe? Like a map of a territory. Or, and this is the big one, is it possible that the map is the territory? What if the fundamental rules of mathematics and the physical laws of nature aren't just similar, but they're actually two different ways of looking at the exact same thing? Okay, so to really dig into that idea, let's look at three of the biggest, most stubborn problems in all of modern science. Seriously, these are like intellectual Mount Everests that have stood unconquered for generations. And what's wild is that they each come from a totally different field. All right, first up, let's head into the world of pure math. We've got the Riemann Hypothesis. This is all about the most fundamental building blocks of numbers, the primes. 2, 3, 5, 7. They seem totally random, but this hypothesis predicts there's a hidden, beautiful order to how they're all laid out. Proving it would unlock these deep, deep secrets about numbers themselves. But get this, for over 160 years, nobody's been able to crack it. Okay, second, we're going to jump completely over to physics, deep inside the atom. This one's called the Yang-Mills mass gap problem, and it's all about understanding the strong nuclear force, the cosmic superglue that holds all matter together. Our theories about it are great. They work beautifully. But we can't mathematically prove why this force is so insanely strong, or why its particles, the gluons, are basically locked up forever inside protons and neutrons. It's a huge gap in our understanding of why stuff even exists. And for our third mystery, we're hopping back to math for the Birch and Swinnerton-Dyer conjecture. Now, this one is fantastically complex, but at its heart, it's trying to build a bridge between two totally different worlds. Algebra, finding solutions to equations, and geometry, which is all about shapes. The conjecture suggests there's this deep, hidden connection between them. It's yet another mystery about the secret structure of numbers. So, there you have it. Three totally separate, massive problems. One's about prime numbers, one's about the forces inside an atom, and one's about geometry and algebra. On the surface, they seem to have absolutely nothing to do with each other. But what if they did? Well, not too long ago, a single author dropped this beast of a paper. We're talking over 700 pages, with an unbelievably bold title, On the Nature of Nature. And its central claim is just staggering. It says it proves not one, not two, but all three of these legendary problems, with a single, unified theory. And what's really fascinating here is how it claims to have pulled this off. I mean, this is really the key question, isn't it? Just stop and think about that for a second. What kind of framework could possibly be deep enough to connect the seemingly random pattern of prime numbers with the raw brute force holding an atom's nucleus together? The answer, according to this paper, doesn't come from math trying to solve its own problems. No, it comes from a totally radical new way of looking at the universe itself. So, this theory, it pulls together three really profound ideas from the absolute cutting edge of theoretical physics. And these three ideas, well, these are supposedly the keys that unlock all three of those ancient mysteries. Okay, key number one is something called celestial holography. And yeah, this is a seriously mind-bending idea. It's the concept that our entire three-dimensional universe, and yeah, that includes you and me, might actually be a holographic projection. That all the information that makes up our reality is somehow encoded on a distant two-dimensional surface, kind of like a giant cosmic movie screen at the very edge of space-time.
The second key is a principle that supposedly runs the show on this holographic screen, and it's called shadow symmetry. The best way to think about it is like a shadow puppet show. You make a simple little action with your hands, that's the tiny scale, and it creates this huge complex shadow on the wall. That's the huge scale. Well, shadow symmetry is supposed to be a fundamental rule of our universe that works just like that, creating this deep, reflective connection between the infinitely small and the infinitely large.
And the third, and maybe the most fundamental key, is a mathematical tool called harm measure. Now this is a deep concept, but here's a simple way to think about it. Imagine you want to measure the surface of a perfect sphere, like a basketball. You can't just use a flat ruler, right? It wouldn't work. You need a method that respects the sphere's own symmetry. Well, harm measure is basically a universal version of that idea. For any symmetrical system out there, it gives you the one and only fairest way to measure it. It's like a universal yardstick that's baked right into the symmetry itself.
Okay, so let's recap. We have our keys, a holographic universe, a special symmetry that governs it, and a universal yardstick for measurement. The crucial question now is, how on earth do these physics concepts unlock those classic, unsolved math problems?
And this is where it all comes together. This is the core claim. The theory proposes a direct, one-to-one mapping. So that hidden pattern of prime numbers from the Riemann hypothesis? The claim is that it's a direct consequence of that shadow symmetry playing out on the celestial sphere. And the Yang-Mills mass gap, that mystery of the strong force, it supposedly just emerges when you apply the universal yardstick, the harm measure, to the forces of nature. And finally, that crazy complex Birch-Swinnerton-Dyer conjecture, turns out it's just a reflection of the fundamental geometry of the holographic universe itself.
So what this is really saying is that these legendary math problems, they aren't separate puzzles at all. They're just mathematical shadows cast by a single, much deeper physical reality. From where we're standing, they look like completely different things, but they all come from the exact same object, the fundamental structure of our holographic universe.
So, where does this leave us? I mean, if, and it's a big if, but if a theory like this were ever proven true, the implications would be absolutely staggering. We're not just talking about solving some old math problems, we're talking about fundamentally changing our entire map of reality. For starters, it would mean that space-time as we know it, the very stage our universe plays out on, isn't fundamental. It's not the bedrock of reality. It's something that emerges, like a projection from that deeper 2D code. Then, the wall that we've always put up between physics and mathematics would just crumble. They would be revealed as two sides of the same coin. And finally, it would mean the most basic rules of our cosmos are just born from these pure principles of symmetry, and the one fairest way to measure them.
And all of that leaves us with one last, really profound question to chew on. If the laws of physics are just the universe expressing mathematical truths, and if physical particles are just the consequences of geometric symmetries, then what is the universe really made of? Are we living in a world of matter and energy? Or are we living inside the structure of mathematics itself?